Whoa, I think this is working. This is test 1 of differential equation today. This is not going to be the full explanation. I got this equation from Paul's Math Notes. Amazing math resource online. Highly suggest checking it out. He's going to do a much more in-depth and thorough job at explaining this concept, this equation, but I'm just going to play around with this. So we have 2xy. We have to first test if this is the exact function. I already know it's the exact function, but I'm going to test for it anyway. So we're going to take dx, or sorry, dy of this, and that goes to 0, and that just goes to 0, so you get 2x. Then you take, I don't think I noticed that was a negative. Oh wait, that's not negative. Sure. We're doing 2y plus x squared plus 1. Now we do dx of this, taking the derivative of this equation, and as we know that will go to 0, that will be 2x, and that will be 0 because there's no x. Wait, did I do that right? I think I just did something wrong. Oh, that's 1. I confused myself by crossing that out. It looks like a... So that goes to 0, 1 goes to 0, this will go to 0, there's no x there, and then the 2 comes down, we have 2x. Cool. So we know these are the same, so we know these are exact. And this should be semi-familiar from usually most people's Calc 3. And then, what do we do? So there's kind of this weird, cute equation we get. This is mx, this is I believe mxy, because we just took the differential, and this is y. So now we do, I could be mixing this up, these could be opposite. Let me think about that for a second. Yeah, I think that's right. So now what we want to do, if say that's m to the x, we want to take the opposite. We did differential in terms of y, let's take the integral in terms of y. So what do we get from that? We'll get write it out, integral in terms of dx, we are going to get I can take that out. That's 3. And technically it's going to be plus a function. I should make this a little more clear. Sweet. Now what do we do? From here, we gotta do, take the integral of this bottom equation, which we took the derivative of last, because this is what this is going to be, as long as we don't have any commonalities in this. So let me do that. 2y plus x squared plus 1. These are nice and easy. Don't have any crazy trig functions. Don't really need to know my Calc 2 that well to do these. We're doing this in terms of dy. So we're going to get a y. Let's see here. Y. We're getting a x squared up. Notice we have like terms. We don't need more than 1. And then we're getting 2y. So we're going to get a y squared. Well, since these are similar and we only need 1, we don't need more than 1, so we're going to get rid of that in our final equation. Looks like, for this exact equation, will look like something like x squared plus y squared plus y minus 3x squared cubed plus c. Now obviously this could be written a little bit more elegantly with usually you do x squared plus I'll probably do this problem over again and explain it much better, but I was just testing this, see if my screen recorder works. Hope all of you guys are doing well. Any more questions, leave in the comments. Have a wonderful day, people.